I'll start recording. All right, so we're live. Okay, so hi everybody, welcome to the TST meeting here. I think this is our first one after the election this year, and so I would like to congratulate Jordan and Andrea for being elected as new members of the TST, and of course to you, Jono, as well too, for being re-elected. So this is going to be a good complement of people. And I think today Jordan had some proposal for discussing some architectural changes that are required in order to support the ISSU going forward for release 14 and onwards. So I'm going to give Jordan the presentation rights here, and I'll let you take it from here. You got it, Jordan, right? Ah, perfect. There we go. No worries. I just wanted to make sure.
All right, so
hey, Bob.
What's up?
How you doing? Good. Nice to see you. Yes. Oops. Were we recording?
Yeah. sorry, I'm going to just walk in. I haven't seen it in a long time. But carry on, Jordan.
Okay. Yeah. So the ISSU brigade and myself have been meeting several times over the last few weeks to discuss the current implementation of ISSU and how it can be improved over the long term. So last week we came up with some ideas about some future architectural changes that we'd like to propose and discuss. So a little bit about the current ISSU architecture. So basically the sort of workflow for ISSU is that at a high level, you upgrade a minority of the ONOS cluster, switch mastership from the old version to the new version, and then upgrade the remaining nodes and rebalance masters. And during that process, part of what we do is isolate state changes inside primitives so that a new version can change some of the distributed state without impacting the old version and vice versa. And so this is sort of what the two main phases of ISSU look like. So this sort of shows in green a newer version, basically upgrading two nodes to a newer version, switch mastership over to the new version, and then upgrade the rest of the nodes. But the complex aspect of this deals with the Raft partitions. So part of the goal with ISSU has been to ensure that we can keep improving primitives and introducing new features there. For example, Charles and I a few weeks ago had to add a distributed lock primitive for the route store. And so we really need to be able to preserve the ability to make changes at that low level. But there's a lot of complexity in doing that because Raft is a quorum-based system. And basically changes to primitive state machines need to be replicated on other nodes, and when there are multiple versions running and you're introducing new features in state machines, that's a complex process. And so the way that we handle that currently is when a node is upgraded, we basically duplicate the Raft partitions, form new partitions during the upgrade. Once the upgrade is complete, delete old partitions, and this allows us to isolate state within each version and introduce new features. And so this is sort of what it looks like. Essentially, this is showing in orange version, the old version's Raft partitions. During the upgrade process, those are copied, and all the existing state of those old partitions is copied into new partitions that are only hosted on the upgraded nodes. And this allows us to introduce new features and replicate changes to new features. But the problems with this, are obviously there's a lot of complexity, and one of the issues is that this adds a lot of overhead to ONOS during the upgrade process. So here we're basically doubling the number of partitions, doubling the number of state that's held on disk, doubling the amount of state that's held in memory, and that can just add a lot of overhead. And then there's another complexity here, which is this makes it very difficult to synchronize state changes across versions. In some cases, we need, during an upgrade, after some nodes are upgraded, we still, in a lot of cases, want state changes on older nodes to be propagated to the newer nodes and vice versa. And with the Raft partitions being totally separate after they're forked, that process is very difficult. Basically, we have to proxy changes from old nodes to new nodes and do lots of complex things like that. And so we spent a lot of time last week discussing this and how we could improve the architecture to sort of reduce the overhead for ONOS and reduce the complexity of this process. And so what we want to propose is separating the Atomix cluster from ONOS. So basically, and this has been something that's been sort of in process for a long time. There's been a long-term refactoring of Atomix that I've been doing in the interest of supporting separate processes. And so what we'd be doing is basically moving all the Raft partitions into a separate Atomix cluster. And this allows us to, instead of versioning primitives by splitting Raft partitions, this can be just pushed into Atomix as a feature of Atomix, versioning the actual state machines themselves. And we think since this work has been ongoing already, we should be able to deliver it in 1.14. And so this is what it would look like. This would be the sort of new architecture. It's bugging me. Yeah, so I mean, ONOS obviously connects to an external cluster. Nobody's surprised about that. And so the benefits of this that we see are obviously it simplifies upgrade management, which was what pushed us to this. And like I said, we push versioning and isolation, all these things that we need for upgrades into Atomix and let it deal with them without having to manage Raft partitions during upgrades. Obviously, a benefit of this is that there's less overhead for ONOS processes, both during upgrades and without upgrades. You know, one of the things we've seen is that sometimes when something goes wrong in the Raft cluster or in a Raft cluster, it can affect the performance of the ONOS CLI and things like that. And by moving it into a separate cluster, we should mitigate a lot of those issues. Obviously, we can introduce new bug fixes into the Atomix cluster independently of the ONOS cluster, and scale ONOS independently of Atomix. That's why, obviously, like this drawing shows a 3-node Atomix cluster and a 5-node ONOS cluster. And then we get true high availability for ONOS controller nodes. So currently, what happens when multiple ONOS nodes fail is not exactly clear, but because it depends on which nodes and things like that. But most of the protocols that are used inside ONOS outside of Raft can tolerate a failure of all but one of the nodes. So we get a lot more clarity around the types of failures that the ONOS controllers can handle and push the quorum-based failures into a separate cluster. And so given this architecture, the new upgrade process, well, at least for upgrading the entire system, would be a rolling upgrade of Atomix to introduce new features and operations prior to starting the ONOS upgrade protocol, and then pretty much the same protocol we preserve for ONOS. And so new features and new operations are introduced into Atomix before they're ever attempted to be used by ONOS, so we don't have the same problems that we had with the current architecture. And then, like I said, we push state isolation versioning of primitives into Atomix as well. And so this is sort of this sort of shows the new upgrade process. So this basically in orange is the old version of the cluster, and green is the new version of the cluster. So upgrade Atomix, upgrade a subset of ONOS nodes, switch masters, and then upgrade the rest of the nodes. And obviously also you can upgrade Atomix without upgrading ONOS or vice versa. So there's one question that we're unsure about here, which is what do we do to go from, if we introduce this in 1.13, how do we support ISSU from 1.13 to 1.14? I think there are two ideas there. So one is that we can just not support ISSU from 1.13 to 1.14. In that case, we could provide offline upgrade scripts and potentially use it as an opportunity to introduce semantic versioning for this reason. But I still think it's feasible to support some upgrade. It would be complex, but we could still do ISSU from 1.13 to 1.14 by, we should be able to reconfigure Raft partitions to essentially move them out of ONOS during an upgrade. But so the point being that we can, if we need to, support ISSU from 1.13 to 1.14. So that's the proposal. Basically just moving Atomix into a separate cluster. And I'd love to hear feedback and thoughts on it.
So Jordan, I mean, I'm not an expert on this, but it seems to me that this introduces kind of a whole new set of failure modes. Because previously, as I understand it, Atomix was a library that's linked into ONOS. Or is that, and now we have this, now we've decoupled it, and so there are these other paths which are now, could now fail, which previously couldn't fail. So can you, I mean, can you prove that this is actually, that this doesn't break correctness, I guess?
So yeah, by separating it, I guess there's a little bit of a trade-off here, but to me the benefits far outweigh the risks. So I mean, in terms of correctness, we're still getting the same thing, because really the Atomix, when it's in the ONOS process, behaves exactly this way, and there's actually very little refactoring we have to do to even separate it from ONOS. So we're getting the same semantics from a client's perspective. Yes, we're putting some gap between the ONOS process and Atomix, but there's a huge benefit to that. Like I said, in terms of managing the overhead, scaling ONOS independently of Atomix, and vice versa for different sizes of data and things like that. And in a lot of ways, what happens when an ONOS node fails becomes a lot more clear to me in this architecture.
So David has some questions you should probably answer too, but just to follow up on Jordan. So if I understand it correctly, or I mean, as I see it, the sensible thing would be to say if ONOS loses its connectivity to the ONOS cluster, if an ONOS node loses its connectivity to Atomix out, sorry, then it basically is considered failed and just, essentially, correct?
Yes, that would be correct.
Probably it commits suicide, although it doesn't really matter because basically everyone else can sort of shun it anyway, right?
Okay. So first, couple of things. I just want to make sure you guys pay attention to the chat. David Bainbridge, he's in a library, so he can't talk. So he asked a couple of questions.
Yeah, I think his question, his last couple of questions are very important regarding which path to take.
Yeah, and I'm primarily interested in the second, kind of in the last one, which basically where the ONOS cluster now being effectively, sorry, the Atomix cluster now being effectively a separate process. That has some implications to how the data is shared between the Atomix cluster and the ONOS as well, right? In terms of efficiency and potentially, how do you see that in terms of caching? Would basically all of the data access would go directly to the Atomix cluster, right? There would be just basically remote procedure calls effectively, right?
Yeah, I mean, so my thought about this is that very frequently, probably a majority of the time, operations are going to other nodes anyways, because you're communicating through the Raft leader. So if node 3 is talking to partition, or node 4 is talking to partition 1, and partition 1 is on nodes 1, 2, and 3, then it's always making a remote call.
Yeah, I see. So
especially for they're always going to the leader, which has a much higher chance of being on another node than on the node that's performing the operation. Then we still preserve caching. So I mean, all the primitives that do client-side caching still benefit from that type of thing.
Right.
So you're saying that the ONOS nodes still cache all this state? It seems that this could introduce a huge amount of sort of, additional kind of latency and synchronization overhead.
But but Bob, as Jordan said, right, we do that today effectively. So today, often what happens, we make the call in the same process, but then to the Atomix cluster, but the Atomix cluster has to make a remote procedure call, so to speak, anyway, to access the data remotely.
Right. But what you and David just seem to be saying is that, now those, those RPCs that you had to pay to act to truly remote nodes, now you also have this additional overhead of everything that was previously just like a Java object reference or something, is now an RPC into Atomix. So that sounds terrible, right?
Well, I suppose we would have to empirically verify what the cost of that, of the kind of a local process to process hop is. Yeah.
Yeah, so David actually points out another point, which is like, if we're going to go to all this effort to build our own external database, why not just use another one that already exists?
Well, I'm not sure that actually would solve a problem, right? Because we have a number of kind of fairly tailored primitives that things like Cassandra or Hazelcast don't necessarily provide.
Yeah, I mean, the answer is that the refactoring that's necessary to separate the Atomix cluster is I could do it in a day, literally. The amount of work that it would take to switch all the primitives onto some other system would be massive.
Yeah.
Well, that's kind of inspiring, right? That implies that you should just do it, and then you can actually measure the overhead, right?
Yeah, I think that would be a totally realistic thing to do.
Going back to David's other question, your last slide basically said that you have these two paths. One is like incurring this massive kind of one-time effort for limited payoff, and so the question is that justified based on customers that really need it?
Yeah, this is what I'm not sure about. I'm not sure about whether our customers would need this or not, and I think I'm not the one to make the decision about the path here, but we need feedback from customers. I don't know enough about current deployments. I'm not even sure if.
Yeah, I think that's a discussion we can have separately, probably.
Yeah, I mean, my point is that it's feasible to do. It would be a complicated process.
I like what you're sort of implying, which is kind of an on-demand thing, which is basically, you can easily proceed with number one, and then if people scream about it, you could potentially implement number two, or maybe not scream about it, but if they give you feedback saying they really, really need it, right? Then you can judge whether two is what you want to do.
Yeah, David had a question regarding whether it makes sense to start looking at this as a Docker thing. I would treat it separately, David. Clearly, we already support Docker images, and we would probably provide a Docker image for the Atomix cluster as well. But I would leave that separate right now. I don't want to get tied to Docker or anything specific.
Yeah, I just make my standard anti-Docker comment, which is that frankly, Java apps should never need Docker. Just saying.
Because of the work the ISSU Brigade is doing, we will be ensuring that this is working with Docker and Kubernetes because of the work we're doing it for.
It should just work, but right, I mean, Java should just work anyway if ONOS does its job properly. I mean, it's something that I agree that additional work needs to be done, but it's certainly a solvable problem. Then you could basically not worry about Docker ever.
So my question was, with this proposal, is there still the concept of an ONOS cluster, or is the cluster just Atomix and ONOS is just kind of a client of that, right? Like, do ONOSes talk to one another, or do they always communicate through the Atomix backend?
No, I think yeah. From the perspective of ONOS, really nothing is changing. We're just moving where the actual Raft servers are. So currently the Raft servers are inside the ONOS processes. We're just moving about. So all the same things, all the same architecture within ONOS would exist after this. And I think that would be something we could consider revisiting later. But yeah, ONOS nodes would still have to communicate with each other directly. Something like an eventually consistent map is still totally hosted on ONOS nodes and things like that.
Oh, okay.
But does this relax the, well, does it change the sort of scaling of the cluster, right? Like, because currently we say we support sort of odd numbered, like 5, 7, 9 size clusters. But with this, now that we don't have the Raft cluster in the ONOS process, can we scale ONOS out to, you know, tens or hundreds of nodes without a lot of overhead, or is that still not the case?
No, I think that's totally, that was one of my points is this allows ONOS and Atomix to scale totally independently. There's a lot of overhead to managing Raft clusters inside of the process. And I mean, that goes for failures, but also for scaling. So an ONOS controller should be able to, a 5-node ONOS controller should then be able to tolerate 4 failures given the correct configurations, and it should be able to scale up to a lot larger than Atomix.
Yeah, and I'm gonna also point out to the chat from David. David has a suggestion which I think is spot on. This, at least in my view, it seems like this might enable kind of a central or just reasonably centralized collocation of the Atomic cluster, and then have potentially a number of remote sites accessing that cluster remotely, providing local access to the devices.
Yeah, that is kind of interesting. I think it's one of those things you can test empirically as well. And I know that, I mean, like ONOS.py, you can potentially add delay between, different nodes in the ONOS cluster or the Atomix cluster.
So just go ahead. Was there?
Oh, I was going to ask, how would this affect our testing infrastructure and things like that? How much work would it be to update that type of thing to work with this new architecture?
Well, yeah. So actually, this is what I was kind of heading to, right? We could potentially make this reasonably transparent by, at least in my view, I don't know, maybe I'm missing something, by modifying the ONOS install tool that we use in, at least locally, and potentially clearly modifying the Docker image to effectively provide installation of the Atomix cluster stuff alongside with ONOS for right now. Just, clearly this would be just short term as a transition thing. This would clearly, for every ONOS process, it would install the Atomix node. But that means they would effectively stay paired up. Now, that may not be something that we want long term, right? Where we basically would like to designate 3 nodes. Let's say you have a 5-node. Well, I actually don't know. I guess I should think about this a little bit more.
Yeah, I mean, I don't think that necessarily answers the testing question, which is independent. But I think you've hit the nail on the head that having to manage 2 clusters and 2 installations, and David points out a question as well. That seems to kind of double the complexity of the installation and management of the cluster.
Well, no, that's what I was talking about. That we could. I mean, today the ONOS install effectively deposits ONOS bits and installs them as a service and configures things initially by default. We could do the same thing for both ONOS and Atomix in a single swipe, and so the existing tests and testing infrastructure would basically see that as a single step, even though underneath it resulted in spawning 2 separate services. That's what I was aiming for. And then eventually, as we see the need to now start to decouple the cardinality of the ONOS cluster from the Atomix cluster, the 2 different cardinalities now, then we may want to start modifying our test suites and test tools to divorce it.
What do you think the overhead will be for regular users who aren't using this ONOS install script? Because now it seems they'll have to install and management.
Yeah, well, so right. Well, so we already allow developers to start ONOS locally, and this is done through Buck, and it's also done from the same image that's used as a main distributable, which is the ONOS*GZ. And I suspect we would do the same thing. We would just spawn two processes. But these wouldn't be services this time, but they would just be separate processes. One for the Atomix sort of node, in this case, just a single node, and one for ONOS node. So again, it would be, the idea here is to keep it transparent for developers, right? Though there would be two separate processes.
I was talking about, thinking users and network operators.
Oh, for users and network operators, right? This is, I think, something where we have to give it more thought, in my view, because I think this is where we need to start paying attention of how this integrates with Docker or Kubernetes or something like that. Most likely, I think what we would want to do is provide a Atomix version of the Docker ready to go, and ONOS version of the Docker ready to go. And we would have to modify probably some of the recipes for installation.
Yeah, definitely. And I think, I note that those recipes will, incur an additional sort of configuration and management overhead that now you have to figure out, how many Atomix nodes do I want? How many ONOS nodes do I want? What are their appropriate configurations? There's that sort of, mental load, and then actually the administrative load of actually having to enter that configuration.
Yeah, and you're absolutely right. I mean, we would have to, document this clearly, because we can hide the details, but if something goes sideways, right, it's important for the person to know what's kind of underneath the hood so that they know how to debug it. And so we would have to document this and provide, clearly update all of our existing documentation to indicate that this is no longer a single process entity with respect to a single.
Going back to testing, there are obviously these new test cases where we disconnect an ONOS from the Atomix, we kill off an Atomix separately from an ONOS process and stuff like that. It seems like there are a lot of new tests.
Yeah, and that's what we effectively had to do, right, in the old days when we were working with Cassandra as Zookeeper, where we actually have two separate entities that we had to keep in mind, and there were test permutations where they would, different entities would die from that triad. For sure, it's kind of the low-level test cases will probably get a little more complicated, but I think we should be able to add those over time. But right, that's what we had to do with the old days, didn't we?
Yeah, we did have the storage separate from the ONOS process.
Andrea?
Yeah, I had another question. What would be the performance benefit of having a non-one-to-one mapping between the ONOS instances and the Atomix instances? Would there be any? Or we just do it because it's better for ISSU?
So there's performance and scalability. A larger, let's say your cluster for some reason stores a lot of state inconsistent primitives, like routes or something. You scale the Atomix cluster. You can use a 3-node ONOS cluster and scale the Atomix cluster to 7 nodes and store more data. Or a larger cluster can have more partitions, so you get more parallelism, depending on if you need more throughput and things like that.
That's very interesting. Could this be somewhat automated?
In what way? Automated based on what?
In the sense that based on the load of the ONOS instances and the number of data, you automatically spin up or down.
Yeah, I think it could.
That's kind of an interesting idea, like auto-scaling, right, for ONOS. I think, it's kind of a neat idea. If in fact it's true that you need this horizontal scaling for I guess state and device management purposes, which I've never seen in practice as something you really need, but because I can imagine that it could be possible. David had some comment. What's KAS?
Kubernetes.
Oh, I didn't know the abbreviation.
Yeah, no, I think for now we should start simple and just start with 141 and modify our kind of the ignition and startup scripts used by both test and developers to make it as transparent as possible. And you said you should be able to make the change reasonably simply, right, Jordan, to decouple the two?
That's very simple. Yep.
Okay. So I would suggest we try it, especially if it's a low investment from your standpoint. That I would suggest we try it and see how that goes. I would probably wait. This is something that we're gonna have to do in 114, right? Because I don't think that's something we want to take on in 114. Sorry, in the 113, the existing release.
Yeah, definitely.
Given how close it is, right? We effectively have a code freeze date next Friday, so I'm thinking this might be a bit too risky. So I think on a 114 branch, we could certainly try it, assess how it works, and go from there. I mean, and as far as the upgradability from 113 to 114, we'll have to discuss that with our potential deployers, what the impact of that would be, whether we invest in a online or offline upgradability.
Sounds good. Yeah, so maybe after ONS, I'll put together a test.
Yeah, and as David pointed out, right? I mean, if this works well, then I think one of the hurdles for disaggregating the ONOS process itself will probably be sort of proven to be out of the way, because one of the concerns there was what is the impact on performance in terms of having not having effectively local access to the data. If that proves to be a non-issue, then we might be able to start separating the apps apart from the core in terms of the process as well as the source code.
That should be interesting.
Yeah, I've also thought about ways to, this is a little bit of a digression, but I thought about ways to do fast local communication in ONOS, between like external apps or between ONOS and Atomix. For example, use a shared memory segment where everything's stored in natively in protobufs or serialized format, things like that. You might be able to get rid of the overhead for things if they're located on the same node. There are other crafty things that could be done as well, like put ONOS on an RDMA cluster, which is something you can certainly do with SDN and with P4 switches or whatever, or actually just off the shelf.
Yeah, is there any other comments from the forum? I personally did not have any, at least not for now.
I actually, at one point, the last, I think TST or maybe one previous, people talked about this, is how important is it for ONOS to, ONOS has gone down the path of caching all the state. And, have people, and there's this idea of sort of more stateless ONOS where everything, all the state is sort of, in the switches or elsewhere. Do you think this is, related to that or a step in that direction, or is there an orthogonal investigation towards like stateless ONOS?
I would think that it would be orthogonal.
Yeah. I mean, not really stateless, but just less state, I guess you might say.
Well, yeah, or we just basically outsourcing the management of the state, right, to a separate process.
Right.
But it's still a control plane resident entity. It's just
right. The question, where does it live, and does it live in ONOS processes? Does it live in Atomix? Does it live in a database? Is it just cached in ONOS processes? And is the truth either generated dynamically when you need it, through computation, or is it fetched from the switches or things like that?
Yeah, and so that's the last two bits that you just said would be that would be change in strategy, but I don't think we're doing those last two things, at least not for now.
Yeah, I mean, that's certainly not the path that ONOS has taken at the moment, but it might be a perfectly good path for some controller, which may or may not be ONOS.
Yeah, and then there's some merits to it, but there's also some complications, right? Because if you're dealing with low-level state, let's say like flow rules, that are synthesized as a result of some higher-level policies like intents or routes or whatever. Those high-level entities are not retained by the environment. They're just simply manifested in terms of the low-level entities. And synthesizing those high-level entities from the low-level constructs is a difficult thing, right? And it's not necessarily deterministic either. So we will we'll have to maintain some high-level policy anyway. Whether or not we keep track of the low-level construct is a separate subject. Sorry, I'll take a break now.
No worries.
This is more of a not a very technical question. I think this Atomix decoupling from ONOS could be profitable for the library itself, because maybe somebody else could use it as a standalone element. Or are we looking at least exposing that somehow?
Well, it already
is. It's already a separate.
Yeah.
And it has its own distinct users from ONOS actually.
How about the distributed, things like distributed hash map and stuff? I haven't looked recently. Are those actually separated out of ONOS currently as a separate project, or is the intent to do that at some point so that people could use them independently of ONOS?
So that's what I've been in the process of doing for the last 6 months. That's been sort of a long-term project of mine, and so part of 1.14 would be that. They're already already moved into Atomix. We just haven't removed them.
Okay, cool. Yeah.
Oh, thank you, Jordan, for putting this together. This is great. I like that initiative. So I think unless there is additional suggestions, questions, or concerns, we can probably adjourn. Going once. All right.
All right. Thanks, everyone.
All right. Thank you.
Thanks, everybody. Bye-bye.
All right. So next week we have one more closing note. Next week we have the ONS, and the next TST meeting will be 2 weeks from now. All right. Talk to you then. Bye-bye.
Bye-bye, everybody.